to engage your brain, okay? This is the part that kind of, you thought you knew it pretty good. All right, well, this might screw you up a bit, okay? Rational exponents. Well, what have we been doing so far? Is that a rational number again? Is any fraction a rational number? Yeah. Remember, if I can write it as a fraction, right, like that, which is 0.3333, repeat, that's rational. If it repeats or terminates, that's a rational number. So what you've been doing has been rational. All they're saying now is, now we get some fractions for exponents, okay? And we all love fractions, right? We'd much rather add 1/3 and 2/5 than 4 and -2, right? No, I know. Sometimes we're going to need a common denominator to add or subtract fractions. The rules, guys, are all the same. Nothing changes there. It's just a little more involved when this isn't a nice integer or whole number or natural number. It's going to be a fraction. Okay? So, complete and evaluate. Let's investigate. Hopefully, when we do these, it's kind of like, aha, right? I'm not just going to throw it out there and go memorize it. Hopefully, we can kind of come to a conclusion. If you follow this, great. And if you don't, well, I can tell you some way to memorize it. Okay? We can get the same mark. So, root 5. That says the square root of 5. All right? Times the square root of 5. Can I join these? We've done this. What's that? The square root of 25. Think of it this way. Root 5 times root 5. I can also write that as root 5 squared, right? Because like 3 times 3 is also known as 3 squared. So that's root 5 squared. You know 5 squared is 25, and the answer here, of course, is 5. 25 is a perfect square, right? Let's look at this one. 5 to the 1/2 power times 5 to the 1/2 power. Do we know a rule to do this? Yep. Am I multiplying with the same base? What do I do with my exponents? Yeah. What's a half and a half? If you eat half a pumpkin pie, oh, that's coming up next month. Nice. And you eat the other half a pumpkin pie, because no one was looking, how much of the pie did you eat? The whole thing. 1 whole pie. Half and a half is 1. Don't multiply them, we're adding them, right? Okay? And 5 to the 1, that's just 5. Okay? So far so good? Yes? You can't see? Are you blind? I guess you're going to need them then. Yes. Okay. If root 5 times root 5 gives me 5, but also 5 to the 1/2 power times 5 to the 1/2 power also gives me 5, let's go way out on a tree limb here. Let's come to a conclusion. What can I say about this and this? Do we think like they're maybe like the same? Deduce a meaning for 5 to the 1/2 power. Yeah. Okay. This is something, guys, you're going to want to stick in your noodle. All right? So stick this in your noodle. 1/2 power is the square root. Okay? That's what that says. 5 to the 1/2 power is the same as the square root of 5. All right? If we don't believe me, what if I said to you, well, what's 16 to the 1/2 power? Hey, let's find out. What is 16 to the power of bracket 1 divided by 2? What do you think it is? Well, I just told you, anything to the 1/2 power means square root. What's the square root of 16? It is 4. Okay? So we just kind of showed you that maybe that is like going to work. Now I'm telling you, like stick that in your head. Okay, that's something we want to memorize. It'll be easy marks if you do. 1/2 power means square root. All right, next one. Complete and evaluate the following. Cubed root of 2 times the cubed root of 2 times the cubed root of 2. Can I join those all together and say that's the cubed root of 2 times 2 times 2? We learned this law in radicals. Yes, we can do that. We can join them all together. What's 2 times 2 times 2? And who's memorized what's the cube root of 8? Yeah, it's 2. What do I multiply by itself 3 times to give me 8? It's 2. Let's look at it in terms of a rational exponent. Now, this pie, I'm going to cut in thirds. And I'm going to eat a third of it. And then I'm going to eat another third of it. And then I'm going to eat another third of it. What's a third and a third and a third? It's the whole pie, yet again, right? So remember, when we're adding or subtracting fractions, we need a common denominator. And if you have one, then you just add straight across. 1 and 1 and 1 is 3. And 3/3 is 1, right? Okay? So, deduce a meaning for, just like we did last time, what can I say about this and that? Think they might be the same? 2 to the 1/3 power is the cubed root of 2. One-third power is cubed root. Okay? Stick that one in your noodle. Do you guys remember the cubed root of 64? It's 4. Guess what 64 to the 1/3 power is? Bracket. You got to bracket this, or are you just taking it to the 1 power? Oh, what do you know? It works. Okay? So, should that be an easy mark? What is 25 to the 1/2 power? 1/2 power is the same as what? It's the same as the square root of 25, which is 5. Did I just do this one? Yes, I did. That's the same as the cubed root of 64. Okay? Oh, 1/4. I haven't done that. You remember this radical, if there's nothing there for an index, what is it? 2. 1/2 power means second root. 1/3 power means cubed root. Guess what 1/4 power means? Fourth root. What times what times what times what is 81? Some of us got it. Yeah, okay. Don't believe me? Try it. 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay, does it just have to be numbers? Like, can I do this with an x? I don't know what x is. Anything to the 1/2 power means square root. Okay? Write the following in radical form, and that's all we can do. It should be an easy mark if you did what I asked and stuck that in your noodle. Okay? B to the 1/3 power can also be written as a radical cubed root of b. 10th, he didn't do that. He didn't teach us this. Do we see a bit of a pattern happening here? 3 cubed root, 4 fourth root. What root of p is this? 10th root of p. Yeah, okay. And the nth root, 1 over n, this 10, 10, n, n, nth root, yeah, that's what it means, okay? The nth root of a. What's he talking about? That's not even English. Well, yeah, it is, okay? Okay? So that were fractions, but everything had a 1 on top. We need to do it with bigger, uglier fractions, like that one, okay? Like, it's not 1 over n, it's m over n. M and n can be whatever we give you. All right? Complete and evaluate the following. So, we did this. The square root of 5 times 5 was what? It was root 25, which is 5. Guess what the square root of 7 times the square root of 7 is? The square root of 49, which is 7. Guess what the square root of 41 times the square root of 41 is? Do we see a bit of a pattern here? It's 41. What's the square root of, I don't know, 241 times the square root of 241? Don't believe me? Put it on your calculator. Okay? So what is the square root of 5 cubed times the square root of 5 cubed? What did I have under the radical sign? That's what I get. What do I have under this radical sign? That's what I get. Okay? 5 to the 3 over 2. What's that as a decimal? 1.5. Times 5 to the 3 over 2. Am I multiplying with the same base? What is 3 over 2 plus 3 over 2? I have the same, got a common denominator. 3 and 3 is 6. How many times does 2 go into 6? Yeah. What's 1.5 pies and 1.5 pies? 3 pies. Okay? And we're doing the same thing again. Deduce this. What's a deduce? What? Okay. This times this gives us 5 cubed. But this times this also gives us 5 cubed. So what's another way to write this? What can we say? Do we think this is going to be the same as that? Well, it is. All right. One little more investigation type thing. Okay. Let's back up a bit. Cubed root of 2 times the cubed root of 2 times the cubed root of 2 gave us 2. So what do we think the cubed root of 4 times the cubed root of 4 times the cubed root of 4 is going to give us? God, you guys are smart. Okay, or whatever we have in here, if we multiply it 3 times, professors will get mad with this, but it's like this cubed root cancels out with that exponent, and you're just left with 2 squared. Okay, when I multiply these 3 times. And what's 2/3 and 2/3 and 2/3? 6/3, right? Otherwise known as 2 squared. Deduce a meaning for 2 to the 2/3. Must be the same as that. Look at this little 3 here. Do you see where there's a 3 in the radical? Isn't that the index? Look at this little 2 on top. Do you see where that is in this whole radical? That's like the exponent on 2, isn't it? We can maybe come to a little conclusion here. Write the following in radical form. I don't want it. This is as an exponent. I want to write it as a radical. Okay, let's look here. 2, that's my base. That stays the same. Here it's x. Where do you want to put this 5 and this 3? What happened up here? The number on the bottom went where? This denominator became the index, didn't it? So this denominator, let's put it where the index is. The number on top, the numerator, that went where? That became the exponent on x. That's how we do this. Okay? So, like I said, it is pretty confusing, okay? Like there's grade 12s who can get a really good mark in Math 12 and, you know, they wouldn't be able to explain this to their kid brother in grade 10. Okay? If you followed this, great. But at this point, don't worry, we can all still get the same mark. Okay? That's what you do. What I just said, I'll write again on the next page. But let's just do a couple more. I want to write this as a radical. Okay? The bottom number, put it as the index. The top number, put it as an exponent. Okay? How am I going to write p as a radical? What do I do? Who's got it? Taylor? Okay, where did this 5 go? You mean the index? Yep. And the 5 is the exponent for p. Okay? A to the m over n. Where does the n go? That's the index. Where does the m go? That's here. That's the exponent. Okay? That's how we do these. Let's go right down to the rule. Rational exponents. This, guys, is the part you want to highlight and box. That's our rule. Okay? I don't care what n and m are. Where does the n go? That is the denominator in the exponent, a fractional exponent. That goes to the index. Okay? Where does the m go? That's the numerator. That becomes the exponent. Here it doesn't say that in English, does it? Okay, so we're going to write it. The top number is the exponent. Top number of a fraction is called the numerator. I'm not even going to write that word here. Okay? The bottom number, by the way, # doesn't mean hashtag, it means number, right? Before there was ever Twitter, okay? Doesn't just mean hashtag, that means number, okay? But if that screws you up, then write number. All right? Bottom number becomes the index or the root part, because if you don't remember that term index, well then that's not going to help you. If you don't remember root, then maybe, hopefully, you'll remember radical part. All right? That's it. Should be easy marks if all you do is remember that. Okay? So, m, set of all integers, n is the set of all natural numbers, and a can't be 0 because you can never divide by 0. Okay, this makes the really, really smart people who wrote this book happy. All right? Don't even worry about it. That's the rule. What happens if it's negative? Oh my God, that's even uglier. Well, remember, just like before, if you have something negative, how do I make that positive? Put 1 over it, okay? And it doesn't matter if that's a fraction then it's 1 over the fraction. And then if I want to write that as a radical, okay, the bottom part is the root part. I don't have to put a 2 there, but I can. The top part is the exponent part. That's exactly what this thing looks like, okay? All they're doing is making it positive first by putting a 1 over it. But it's exactly the same as this guy, okay? Notice n, that becomes the radical part, okay? That becomes the index. The top one, that becomes the exponent, just like we wrote there. Okay? Couple of examples, then you're on your own. I'm going to do the first part first. Write this in radical form. I will evaluate it in a sec. We got to see something else. So, who's a good quick memorizer? Which goes in the radical part, the 2 or the 3? Yeah. The bottom number is the radical number. The top one is the exponent. Okay? Do I have to put that 2 there in that root sign? No. Remember, if there's nothing there, we know it's a 2. We assume it's a 2, right? That says the square root of 25 cubed. Okay? Bottom number is the radical part. That says cube root. Top number is the exponent. So far, so good? Ooh, negative. Uh-oh. What should you do first when you see a negative exponent? Make it positive. How do you make it positive? You flip it. Everything stays the same. The only difference is that exponent is not negative, it's positive by putting 1 over it. Okay? It's still not in radical form. That's 1 over. How do I write this as a radical? The bottom number is the radical. Top one is the exponent. Okay? 16 to the minus 3/4. First thing you want to do is make it positive. Then make it a radical. 4th root, that's the radical part. Top one's the exponent part. Okay? So always read the question. Write it as radical form. Is that radical form? Yeah. Okay? A lot of your questions will say too, we don't want negative exponents. So as a radical with a positive exponent, and that's already done. Okay? Because the first thing you should do is make it positive. Okay. Evaluate without a calculator. Because I can put it in my calculator and cheat. Let's go back up here. All right. Evaluate. Here's a little trick. Okay? Try to remember this. Because 8 to the 2/3, guys, I can't do that in my head. I don't know what to do. But I know I can split up 2/3 into 1/3 times 2, right? Right? Can we do that? What's 1/3 times 2? Do I need a common denominator when multiplying fractions? No. Just multiply straight across. Is that 2/3? Yeah. Why do I do that? Well, because I know 8 to the 1/3 power is the same as the cubed root of 8. And what's the cubed root of 8? What times what gives you 8? 2. So this is 2 squared, which is 4. I evaluated it. You know what? Let's check. What's 8 to the 2/3 power? It's 4. That's one way to do it. Okay. 2/3, well, that's 2 times 1/3. I could also write this as 8 squared times 1/3. Is that the same thing? Yeah, power raised to another power. Remember, you can multiply them. That's 8 to the 2/3. That's the same. What's 8 squared? That's 64, isn't it? 8 times 8. And 1/3 power means cubed root. So that's the cubed root of 64. What times what times what is 64? Hey, what do you know? We got the same thing. So when you get this, guys, let's just go directly from here. Let's write that as a radical. The bottom part is the index for the root part. The top one is the square part. It doesn't matter which you do first. I could take the cube root of 8 first and then square it. I get 4. Or I could take the square part, 64, and then take the cube root of it. I get 4. You're going to want to do the one that's easier. Okay? Doesn't matter which order you do this in. It's like multiplication. Doesn't matter if you go 2 times 3, it's the same as 3 times 2. Doesn't matter which order. Okay? So you can do either first, right? Square versus cubed root. Okay? So let's look at that. First, write it in radical form. The bottom part is the radical part. The top part is the exponent part. Does it matter which one you do first? Okay. How many people know 64 times 64 times 64 in their head? Yeah. So which one do you want to do first? You know the square root of 64? Yeah. So we're going to do this part first. I know that's 8. Right? The square root of 64 is 8. So that's going to be 8 cubed. That's a lot easier than 64 cubed, right? I still have to go 64 times 8. That's what? 3, 5, 12. Okay? Because manually means no calculator. Okay? As a radical, that's the square root of 4 to the 5th power. You can go 4 times 4 times 4 times 4 times 4. Then try to find the square root of it. Or do we know the square root of 4? So that's 2 to the 5th power, which is 32. Okay? Let's go back to a couple of these and then you're on your own. Do you want to do 25 cubed first and then take the square root of it? Or do we know the square root of 25? Square root of 25 is 5. That's cubed, and that's 125. Okay? Let's look at this weird one. It's 1 over. That's fine. We can still do it. Anyone know 27 times 27? I don't. And then try to take the cube root of it. But maybe we know the cubed root of 27. What times what is 27? Yeah, so that's 1 over. This is 3 squared, or 1/9. Okay? Let's do this weird one. What's our little trick to make this one positive again? Flip it. I proved this last day, so if you're going, why can you do that? Well, go have a look. Check the lesson, all right? The old lesson. You can do that. If you remember that, it'll be a lot easier. Okay? All I do is flip this, and this becomes positive. Nothing else changes. Now what do I do? Well, this applies to the 4 or the 9, or does this apply to everything in the brackets? Everything in the bracket. So that's 4 to the 1/2 over 9 to the 1/2. Do you know what 4 is to the 3 over 2 power? I don't. So let's write that as a radical. The bottom part is the square root part. The top part is the exponent part. Let's do that to the 9 too. Do we know the square root of 4? Yeah, I hope so. That's 2. Cubed. Square root of 9 is 3. Cubed. And 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Can't reduce it. Okay. Check with a calculator. Okay. What's 8/27? It is 0.296 something 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 something. Is that a rational number? Doesn't it look like it keeps going on and on and on? Ah, it does repeat, doesn't it? Kind of confusing, but remember, if you can write it as a fraction, this has to be rational. That's 296 repeat, right? 296, 296. Why do I have this 3 there? That's not repeating. Because it rounds the last 9th digit. Yeah, okay. Anyway, how do you put that in your calculator? This is a little trickier. Bracket 9 divided by 4, bracket to the power of negative bracket 3 divided by 2. Boy, that takes some talent, boys, to put that in your calculator. It's the same thing. Okay? Verified. Check. Double check. Okay, numbers 1 to 6, odd letters. And 9 and 11, which are probably multiple choice. Yep, you bet. Typical. Actually, no, skip 9. I didn't really cover that. 11, typical government exam question. Okay? Multiple choice, rational exponents, negative. Good question. And exactly half an hour to do it, guys. So a couple of you guys aren't here tomorrow, you told me. What are we going to do? Where can you get the lesson? Where can you get the assignment? What? Website? Ooh, that reminds me, I stopped recording.